Welcome to e-Pathshala lecture series. We are discussing on cryptography and network security. Now we are going to discuss on the topic Deffie Hellman key exchange. The objective of this particular topic is to explain how to create session key between Alice and Bob using KDC, and to create session key method refer to the symmetric key agreement, and also we are going to discuss about man in the middle attack. The Deffie Hellman key exchange techniques was first defined in the seminar paper 1976. So actually we have discussed about the key exchange mechanism. Suppose in case of our key management, where we discussed about the role of key, public key authority, public key certificate, how they are going to exchange their public key among the two user. In this, one popular algorithm which is Deffie Hellman key exchange technique, which has been a method for exchanging public key, that is non-secret information, to obtain a shared secret. So Deffie Hellman is one among the method of key exchange between the user who want to share their secret information. Actually the DH, the Deffie Hellman, is not an encryption algorithm, it is just a key exchange mechanism. How efficiently two user exchange their secret information by using their non-secret information. So Alice and Bob, if they are going to be in the part of communication, they are going to use only their public information, not the secret information. From the public information they are going to derive the secret information. That is the core idea behind this DH key exchange algorithm. So DH key exchange have the following important property. One thing is, the shared secret cannot be computed by either of the party without the cooperation of the other. So when a message is shared between Alice and Bob, they can't get the original information without the cooperation of the other. And even the second property, the third party observing all the message transmitted using Deffie Hellman key exchange cannot deduce the resulting shared secret at the end of the protocol. So this is very important in the case of your key exchange algorithm. One thing is, even though we say everything is public, all the informations are going to be shared in the public, but with the help of public we can able to, that means non-secret information, from the non-secret information we can able to get the secret information. But even if I want to get the secret information, definitely there must be some coordination among the users. Second point says that if even the unauthorized person or an attacker or a third party continuously monitoring the information exchange between these two authenticated user, they cannot compute the secret information without the cooperation of the authenticated user. So with this property we need to understand what is the principle behind the DH. So Deffie Hellman key exchange was the first proposed before there were any known public key algorithm, but the idea behind it motivated the hunt for practical public key algorithm. So this key exchange is not only a useful and practical key establishment technique, but also a significant milestone in the modern cryptography. So where we have some of the public key algorithm like RSA, LGAML, ECC, but still this is the first proposed mechanism of key exchange between the two user, which significantly milestone in the history of cryptography. So here the assumption here what they made before going to proceed with their procedure, here first thing, a public key cipher system that has a special property. That means whatever we say publicly known function, the function f is publicly known that takes two numbers x and y as the input, and it is going to give the third number as the output. It is similar to that of our multiplication. So, when I want to use the public information, where I need to use this function, publicly known function that takes two numbers x and y as the input and output as the third number f of x comma y. So, now we can able to understand from the basic principle, choosing x and y as input and getting the third number as the output, which are going to be taken care. So, now we can able to see that Alice and Bob are the parties who wish to establish a shared secret and let their public and private key in the public key denoted by PA and SA, PB and SB. That means public, and PA means public information of A Alice, and SA means secret information of A Alice, and PB is public of B Bob, and SB is public information, secret information of Bob. Now, the basic principle behind this key exchange mechanism is Alice and Bob, they need to exchange the public key PA and PB. So, they have to exchange PA and PB, we know it is a public information, so they need to exchange. Now, as we mentioned earlier, there is one function like your mathematical function, a multiplicative function. It takes two input, that is SA of SA is from Alice and public information of Bob, that is going to be derived some third input, sorry third value as an output. So, f of SA comma PB, that is secret information of Alice and public information of Bob, it combines with the function f where we are going to derive the third output. Similarly, Bob does at other end, he will get the PA, that is from the Alice, public information of Alice, and SB, that is from the secretly stored by Bob, it is also going to give the third output. So, this special property of the public key crypto system, the choice of functions are such that f of SA PB, that is computed at Alice side, is equal to f of SB PA. So, now we can know that they have a shared a secret. So, actually they never exchange their secret information, because Alice never shared his SA, Bob never shared his SB, but actually they are given only PA from Bob to Alice, and PA from Alice to Bob, and PB from Bob to Alice. But after applying the function, both the values are going to be same. So, that is what they are shared as a secret. So, this shared secret can be easily converted by some public means into a bit stream suitably for use, for example in the disk key. So, now they can this shared information can be given as an input for your disk algorithm, which we have discussed in the case of your symmetric key cryptography. So, what we can understand from this particular procedure here is, or the principle mentioned for DH key exchanges, the Alice and Bob never going to share their secret information in public, but they are able to get the secret key by knowing others public information. And also we have another one property to say that even though third party is going to be involved in this particular communication, for example, if Eve is going to be part of this communication, by knowing PB and PA, Eve cannot deduce any secret or shared secret without the coordination of Alice and Bob. So, now we can able to understand, based on the shared public information, we can able to generate a new key. That key can be used for any symmetric key cryptographic algorithm. So, this solves the problem of your DES algorithm. So, now we are going to see how this function is going to be decided, and also what are the parameters which are going to be given as an input for generating their public and their secret information. So, we are looking at the implementation of Deffie Hellman key exchange using the keys of the Elgamal cipher and the function f. So, we know very well in Elgamal there will be two ciphertexts C1 and C2. From that they are going to be sharing the E1 and E2, where it is going to be generating C1 and C2. From that they can able to share their secret information, encrypted information over the unsecure channel. Now, these system parameters which are public, that means in order to design a key exchange algorithm, first thing, as earlier we have discussed, any asymmetric key cryptography, first thing we need to choose a large prime number P. So, this typically of the size of 1024 bits in length, that means around 300 digits of decimal number. After choosing the prime number, we need to choose a primitive element G. So, what is this primitive element? Before going to know about that, so we will see the procedure, then we can understand what is primitive element. Now, based on the system parameters, Alice generate a private key random value A. So, calculate G power A mod P and sends to Bob. Meanwhile, Bob generate a private random value B and calculate G power B mod P and it sends to Alice. That is all. So, once they are able to generate, but the thing we need to remember here is SA and BA, SB, SA and SB, which should be kept secret, because A and B of either Alice or they should not be sharing that information in the public. Now, Alice takes G power B, which is given by Bob. Alice takes G power B and it is given by Bob, and her private random number A to compute the shared secret. So, which is given as G power B of A, where G power B is given by Bob to Alice, A is the secret information of Alice. Now, we can able to get a new value G power AB mod P. So, now this G power AB is the shared secret information which is not actually sent via the transmission channel, but it is computed at other's end. So, meanwhile, Bob also takes G power A, which is sent by Alice, and with his private random value B, they will able to compute, Bob will able to compute G power A of B is equal to GAB. Now, we can able to see that the both the values G power AB, G power AB, which has the shared secret, that is adapted for Alice and Bob for further communication. So, a public key distribution scheme and cannot be used to exchange an arbitrary message rather than it is established as a common key. So, here only the person who want to part in the communication, they will able to see there is a common key and known only to the two participants, not to the third party. So, it is a public key distribution scheme. And what are the things it depends on? As we are taken the public and private information, that is the value of key depends upon participants, and it is based on exponentiation in finite field, that is Gauss field, where it is happens, where we can able to use the exponentiation in finite field, that is with the modulo of prime or a polynomial, where it is considered as one of the easiest way, because as you see the algorithm, no complex things are going to be involved, just it is going to be modular exponentiation. It is easy, very easy in the case of one direction, whereas the security lies on the difficulty of computing discrete logarithm, similar to that of factoring in the case of your RSA algorithm. And also we have discussed about the discrete log problem. If you are given with a power x is equal to b, by knowing a and b, it is very difficult for you to get x. So basically the security lies on the difficulty of computing discrete log, at similar to that of your LGOML. So that is why it is very hard on the other direction. So same way, where we can able to understand, it is easy to compute or easy to encrypt the message on one direction, but without knowing the secret information, to decrypt the message is very difficult in the other direction. So the security of this key exchange also lies on the problem of computing discrete logs. So one way is easy, the other way is very hard. It is very difficult to break this algorithm with by knowing the public information, like public key or public information shared between the two users, PA and PB. As here we use the primitive root. So what is this primitive root? G. The primitive element was used here is G. So what is this primitive root? From Euler's theorem, we know that a phi of n mod n is equal to 1. By considering a power m mod n is equal to 1, GCD of a comma m is equal to 1 must exist for m is equal to phi of n, but may be smaller. Once the power reached m, the cycle will repeated. So if the smallest is m is equal to phi of n, then a is called a primitive root. So we have to choose this primitive root in order to exchange their public information. So if p is a prime, then the successive power of a generate the group mod p. So that is why they are using this for exchanging their public information. So these are useful, but relatively hard to find. So primitive roots are going to be used between, as the function where we mentioned between your Alice and Bob, the function they are going to use this primitive root in order to exchange their secret information. So it is mentioning that if a power m mod n is equal to 1, if it is relatively prime with n, a is relatively prime with n, then must exist m, that is your smallest is m is equal to phi of n, then a is the primitive root. So we have to choose G in such a way that it must be a primitive root. So in this exchange algorithm, the global parameters, that means the publicly known informations, one is your large prime number or the polynomial q, another one is a being a primitive root of mod q. So here a is a primitive root of q, where q is your prime number, large prime number, as we consider as 1024 bits. Now how Alice or Bob, that is each user, generate their key? First thing, the user must select a secret key, xa must be less than q, and from this xa, with the help of our primitive root element a, they should compute their public information ya. So what is the secret here? Xa. We should not share xa to anyone, even to the person whom you want to communicate, you should not share the xa. But what we are going to tell to them? Ya. that is like our PA, SA is our XA. So, each user makes public that the key YA. So, it is very simple to understand this if we understand the primitive root, and also the value of secret should be less than your prime number. Then Y is computed and also it is shared in the public. Once the shared, they will be generating the session key for two users, that is KAB. Between A and B, they need to generate the session key as what we discussed with respect to our symmetric key algorithm. They can use this particular key. So, KAB is equal to A power XA XB, because these two are already given between the Alice and Bob mod Q. Now, YA XP mod Q, which Bob, that is user Bob, can compute. Similarly, YB XA mod Q, which Alice A can compute. Now, this KAB is going to be used as a session key in the private key encryption scheme between Alice and Bob. If Alice and Bob subsequently communicate, they have the same key as before unless they have chosen the new public key. So, here attacker needs an X must solve the discrete lock problem. So, now we look at an example where Alice and Bob wish to share the key. Let us assume that the prime number chosen by both the users Alice and Bob as well as the generator between the both the users is given as 353 is the prime number, A is the generator 3. Now, A is selecting a random secret information 97, B is selecting a random secret information 233. Now, we can able to see that we are getting in YA is 40, YB is 248 based on the G power PA mod. Similarly, G power PB mod, that is 248. Now, what is the shared information between these two? We can able to see, for example, if Alice want to compute using his secret information, that is 97, he can able to get 160 as the key. Similarly, Bob want to get the key using his secret information 233, that is 40 power 233 mod 353 is 60. Now, we can understand that both the values are same. They can able to use it for any communication. This will be act as a secret key. So, this is what we can able to understand without any secret information, based on their publicly known information, they can able to generate their secret keys. So, both of these are vulnerable to man in the middle attack. User could create a random private key and public key Deffie Hellman keys each time they communicate. User could create a known public key and private key and publish in the directory, then consult with used to securely communicate with them, but both were be vulnerable to man in the middle attack, which can be overcome with the help of authentication of key is used in the key exchange protocol. So, now we have come to a conclusion that we understood what is DH key exchange concept, how the keys are generated, exchanged between the user, and also we have understood what is a primitive function, how it is going to be used for generating the secret information. Thank you.